If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in advanced level where you are solving previous year IT JEE questions on definite integral. So in this lecture we will be solving from question number 21 to question number 30. Okay, then let's try to solve this question. Next, if you come to 21, let f be a real valued function defined on the integer this, fx equal to this, then which of the following statement is f double dash, f dash. They are asking whether f dash or f double dash they exist or not. For that you need to find fx. So if you see your fx this one, so if you differentiate this one, this is 1 by x and this is Leibniz theorem. If you double differentiate it, it is of this fashion. Now this does not exist because this can be 0 somewhere. Because you can see if at x equal to 3 pi by 2 it will be minus 1, then it will be 0. And it is interval from 0 to infinity. You can put any value of input. So at some input you are getting problematic. At minus 3 pi by 2, 0 are not included, okay, you are not putting 0. But at 3 pi by 2 also this denominator is 0. So it doesn't exist for all x. Therefore option A is wrong. Now if you come to option B, f dash is existing. F dash is continuous but not differentiable. Obviously it is not differentiable. Just now you have said this is f dash, that is existing, no issue. It is continuous, because you are not putting 0. It is not including 0, it is first bracket. So that is no issue. Continuous plus continuous, continuous. And it is not differentiable because you have seen the differentiation of this one does not exist in that interval. So obviously B is correct. Now if you come to C, they are asking this one. Modulus of that differentiation is less than the original differentiation. So if you see the modulus of this one is this and fx is this one. So if you see your fx, if you try to integrate this one, 1 plus sin t, you can write it 2 sin t by 2 cos t by 2 sin 1 sin square t by 2 plus cos square t by 2 2 sin t by 2 cos t by 2, which will be sin t by 2 cos t by 2 whole square. Ultimately you will get this one. If you integrate this one, you will get something of this fashion. A particular value, suppose x equal to 1, you check some value. If you put x equal to 1, here it is something of this 2.41. If you put it is 1.27. So obviously this one is greater than this one. This is for some alpha, not some infinity. For some alpha, and then from alpha to this is infinity. That is from 1. Here you can think it of 1 or something of this one. So if it is more than 1, then it is said it is less than 1. So at 1 I am saying this one. After some time what will happen? You can see. Because this ln x is continuously increasing. What is the function of ln? This is increasing. So at this will not increase. Why? Because this will decrease if you increase the value of x, and this is always between 1. Because sin x is from 0 to 1. So it is also limited to up to root 2 only, highest it can go. So this side is restricted, but this side there is no restriction. Ln can go increasing after beyond something. So after some time this side will be more than this one. So obviously C is correct. That means after some alpha, this side will be more than this one. Because this is keep on increasing. And this side is limited. So after some time your RHS will be more than, because ln x is unbounded, it keeps on increasing, so it will rise more. So that is your option C. And what is option D? For any value of beta greater than 0, this plus this is less than this. Now because why it is not possible? Because your fx is unbounded. So for any value it will keep on increasing, it is never be bounded. So you cannot say it is less than b always for any value of beta greater than 0. It is not possible because it is keep on increasing. So it will not be bounded. So therefore D is not the correct option. Okay, in question number 22, for any real numbers x, let this is a greatest integer function, you know. F is a real valued function in the interval this. So fx is this, if fx odd they are given, and this is if fx even. So you know this one. What is this one? This one was the fraction part of the x. This is also written a one function x minus box of x, not mod x, it is box of x. So now what is given? If box of x is odd, so box of x, when it will be odd, that means output is 1, 3. So when output is 1, when your x input is between 1 to 2, 3 to 4, 5 to 6, then your output is odd. So if your x is in between something, then your output will be odd, then it will be fraction of that portion. And when it is even, when x is between, when 0 to 4, so between 0 to 1, 2 to 4, 6 to 7. So in that case it is 1 minus of x minus box of x. That is 1 minus, because this one if you take minus, you can write it x minus box of x. X minus box of x is fraction of x. That means it is a periodic nature. So for a particular period, so 0 to 1 it is this, and 1 to 2 this. Again it is coming to this, coming to this. So it is a periodic function, and the period is of 2. First period, first half it is doing this, second half it is doing, then after that it is repeating. So it is a period of 2 cycles. First cycle is this one, 0 to 1, second cycle is this one. So if see, if it is a first cycle 0 to 1, so if your input is 0 to 1, then whatever input you give, that will be 1 minus x, because f is in between 0 to 1. then what is the meaning of fraction of x? It is only x. Between 0 to 1 means whatever fraction it will come, that will give as a output. And between 1 to 2, if it is between 1 to 2, then what is this x? It will take only the fraction part. That is, suppose if you give 1.2, it will take 0.2. So how you will write it? You deduct 1. So that will give you 1.2. So in the first portion 0 to 1, it is 1 minus x. This line, if you can draw, I think you can draw the straight line. It is a minus 1 slope. So it is falling 1 1, this side 1, this side 1, and it is intercept is plus 1. And this 1 to 2, it is x minus 1, rising slope 1, and intercept is at minus 1. So it will be rising slope. So it is periodic, then after that it is repeating. So if they ask you to minus 10 to 10, whatever, you see how many periods, how many cycles are there, you multiply, do integration for one cycle, then you multiply this one by that one. So minus 1 to n, the total length is of 20. So if you divide it by 2, oh, now you can see it is not only fx, it is fx into cos pi x. So you see the period now. So fx is a period of 2 and cos pi x. What is the period of this one? Cos x is 2 pi, so cos pi x is also 2. So both these of 2 periods, so product is also a period of 2. So if you are going from 10 to minus, total length is 20. So in 20, how many cycles? Each cycle is taking 2 time period. So total 10 cycles will be there. So you take integration of one cycle 0 to 2 and multiply by 10. So that's it. So you multiply by 10 from 0 to 2. So 0 to 2, you will break it 0 to 1, 1 minus x, and 1 to 2, x minus 1. And then fx. After that, I think you can easily do this integration. I have changed it 1 minus x into y, then this limit is changed into 1 to 2. Or you can do it keeping as it is and you apply by parts. Ultimately, if you apply by parts, you will do it, your answer is 4. This is just by parts. Here I have done the substitution, 1 minus x equal to y, that's why limit change. Next, if you come to 23, if f is a real valued function defined by the interval this, which is written as e to the power minus x into fx is equal to this, and let f inverse is the inverse of the function, then what they are asking? Differentiation of f inverse, f dash of f inverse at the point 2 is equal to. So you know f inverse of fx is x, that is identity function, it will bring to x. So if you do integration, differentiation, because I need differentiation of inverse, so you always start with this one, f inverse of f is equal to x, because if you know differentiation of this one, then you have to go by this method only. So if you do differentiation chain rule, first you do differentiation of that is f inverse dash invert, then of fx, okay, then you do the inverse differentiation of this one, f inverse x is equal to 1. So it is f inverse then dash of fx, that is inside this bracket, it is as it is, and this is if you take this set this. Now they are asking you f inverse dash at the point 2, so this fx should be equal to 2, because they are asking this one. So you have to think when fx will be equal to 2. You see your fx, this is your fx of this fashion. If you put x equal to 0, then your output will be, because this side will be 0, so output will be 2, because you need when fx, the output will be equal to 2, that you need to put x, so that it becomes 2. So if you put it there, you change f0 equal to 2. If you put x equal to 0, then it is coming 2. So that means if you put x equal to 0, it will be 2. So if you put x equal to 0, it will be f dash, that 2 will be equal to 1 by, instead of x it is 0. So you need to find this one, f dash 0. So next, therefore this is your fx, you differentiate it. Here you apply that Leibniz theorem. Then if you put f dash 0, then you will find this answer, because f0 you already seen, f0 equal to 2. If you put it, you will get that is 1, so it is, sorry, it is 3, 2 plus 1 3, so it will be 1 by 3, that answer is 1 by 3, that is your option B. Next, if you come to question number 24, the first thing what I am coming across is in my mind, there is x square and there is these roots. So what if I take x square equal to y, so that it will be sin y, it will look good, this all these things. So if you put sin y, then 2x dx equal to dy, and these roots will change to this, and instead of dy it will be half dx, or dx it is half dy. So if you put it like this, now if you check this one, ln 6 and ln 2 3, this plus this, what it will give? Ln 6. So which property will give you this luxury to add these two? That is Queen rule. So if you apply this Queen rule, it will be ln 6 minus y, ln 6 minus, so the denominator will be same, denominator will be same, if you add the numerator is also same, so it will cancel out, ultimately you will get 1. So if you do integration, you will get 2y is equal to this, so your answer will be option A. 25, almost this same type of question we have solved in JEE main also. One function is given, fx, this property is given, and r1 is given, and r2 they are asking that it is region bound by this. So you know r2 is the integration of this one between this to this, and r1 they have given. So you have to find the relation between r1 and r2. So you have to include this r1 and r2 together. So they have used this property. 1 minus x. So you can apply, if you add this plus this, then it is 1 minus x only. So you apply Queen rule here, so it will be 1 minus x f1, and they have given f1 minus x equal to fx. So if you open it, or you can add these two also. These two if you add, then it is 2r1 is equal to this 1 minus x, x minus x will get cancelled, you will get, and this is r2. So that is your option C. Now question number 26, they have given something wrong in the question, that's why bonus mark is given. Otherwise you can do it using Leibniz also. Differentiable such that f1 is equal to 2, and it is given 6 into 1 to 6 x ft, this is given, then the value of f2. It was wrong because if you do at x equal to 1, if you put this side becomes 0, and this is 3 f1 minus 1, f1 is 1 by 3, but they have given f1 equal to 2. So that's why it was a wrong question. 27 we have already solved in indefinite integral, that's why I am skipping this one. Now if you come to 28, this one, again if you see this type of temptation, minus pi by 2 to pi by 2, and there is no trigonometry is there, but it is far behind. So you try even and odd, whether it is possible or not. So this is even, we know, and this, to check this one, you put, take this is as an fx, you put minus x. If you put minus x, then you take minus common, to the power minus you can give any time, so it will come denominator, it will come denominator, and that will comes out of log, that is minus fx. So this is odd. So this is even, this is odd, and cos x is already even. So even into even, so these will be even, and this into this will be odd. So this odd portion is always 0 minus a to a. So no need to do this one, you can do this one only. And this is even, so you can break it into two parts. Now you can use that shortcut to find that by parts. Finally your answer will be this option B. 29 we have already solved, that is JEE main, like exact same question, JEE main question number 7. 30 is also same as exact JEE main question number 11. So I am skipping this one.
If you like the video, then press the like button and please give your valuable comments in the comment section.